So today we discuss the last topic of AC current, and that is a transformer. Okay, so transformer. For transformer is a device. Okay, is a device. Okay, need for voltage is AC voltage. Actually, needs a AC voltage is increase or decrease. AC voltage is either increase or decrease. Okay, so the transformers look like this. There is some winding here. There is some winding here. Another winding, two coil here, and one coil is connected to AC main power supply. Okay, that's why this coil is called primary coil. These are called primary coil, and these here, these transformer output. There is some circuit here. There is some circuit here, and there is a blood circuit here. Okay, and these are the output of the transformer, and these are called secondary coil. Okay, these are the primary coil, these are the secondary coil. Now the number of turn in primary coil is a NP, number of turn in secondary coil is NS, and is primary coil EMF, that is EMF of P, and secondary, that is a EMF of S, secondary EMF. Okay, now this condition, okay, the primary and secondary, from Faraday's law, that is EMF of primary, that is equal to minus NP d phi by dt, because here this coil produces a magnetic field or magnetic flux, some part of flux, and crossing this secondary coil, some part of flux, okay, crossing this secondary coil. But here some simple assumption, we consider the all flux in primary, same flux passing to the secondary. Okay, so EMF primary, here EMF is secondary, that is NS from Faraday's law, d phi dt. So these two are the same, so EMF P by EMF S, primary by secondary, that is NP by NS. Okay, and now here is another important, that is a EMF means voltage in primary, that is voltage, these are the AC voltage in secondary. That is the concept of transformer. Okay, now here these two turns are not in same, these two turns are not in same, because NP and NS, the number of turns be different, and that difference create either output voltage is increase or decrease with respect to input. Input here means primary. Okay, so here the mainly transformer property says if the power input transformer primary, power in primary and power in secondary be the same. Okay, so here if both be the same, power be the same in primary and secondary, be the same both primary and secondary. So here the power in primary, that is power in secondary, the power formula, that is voltage in primary, current in primary, that is voltage in secondary, that is current in secondary, power be the same. Okay, so here Vp by Vs, that is Is by Ip. So here that is also equal to, from this expression, that is equal to N of P by N of S. Okay, that's important here. This expression is very important. Okay, when the transformer uses as a step up transformer, for step up transformer, step up. So step up transformer, so output voltage is high. Okay, so means primary voltage is less, secondary voltage is high. So that means NP is less, NS is high. So a transformer is now look like this. These are the primary coil, and that's the secondary coil. Okay, now there's the main supply, there's the transformer output, that is Vs, that is Vp. And it clearly see in the diagram, Np is less than Ns. Np is the number of turn in primary, Ns is the number of turn in secondary. Okay, that means the step up transformer means here that the concept is the number of flux in primary to secondary coil. There's an induced EMF, so here maximum number of flux here. Okay, so that's why output voltage is very high. But keep in mind, if voltage is high, so one thing is down, that is a current. So here current in primary is greater than current in secondary. Okay, that's why the power being a constant. If voltage primary is less, so obviously current primary is high. Voltage secondary is high, so current secondary is less. That's very important, because the power in both terminal, means input and output terminal, or primary and secondary terminal, will be the same. But the voltage or current may be different. If voltage is high, so current will be the less, and if the current be high, so voltage will be the less. Okay. Now, what is a step down transformer? Same concept of step down transformer. So step down transformer, down transformer. So step down means, very easily clear to see, that is a output voltage is lesser than primary voltage. So Vp is greater than Vs. So here Np obviously greater than Ns. Now current in primary is less than current in secondary. Okay, and our transformers look like this. There's that there's a primary, and that's the secondary. Okay. These are the AC source, AC main, that's the transformer. Okay, so current in primary is lesser than current in secondary, because the voltage is primary is high and voltage is secondary is low. That's why these are the step down transformer. Okay, there are basic two types of transformer here, either step up or step down, and keep in mind that the input voltage are always in AC voltage. In mind, the input in AC source. Okay, DC is not applicable here. Okay, so here one thing is mind, keep in mind, the flux in primary crossing to the secondary, and there is an induced EMF. This EMF is that induced EMF from Faraday's law. We get from Faraday's law, and here that is the induced EMF, induced EMF from Faraday's law. Okay, so there is some demerits here. Okay, so some disadvantage. So disadvantage in transformer. The disadvantage number one. So there is a flux leakage. Flux leakage. So flux leakage, not linkage. Flux leakage. There is a design for poor design of core. So there is a poor design of core. If you poor design, there is some flux leakage. If there is some leakage, so there is a voltage mismatch here. Number two, resistance of winding. Due to the resistance, okay, this wire have some resistance. This wire Is a making a obviously there is a metallic wire, so that's wire have a resistance. If the wire have a resistance, there is some energy loss, okay, producing a high current. So or low current, if a high resistance is low current, low resistance is high current. Okay, so due to that energy loss, where have resistance, where uh, that's why there is some delay loss here. Number 3, AD current. So in alternating flux, magnetic flux, there's an induced eddy current. Alternating magnetic flux are induced eddy current. So they are in the core, iron core, and reduce that current by laminating the core. Okay, if I laminate the core, okay, if I laminate the core, there's a reduce of eddy current. So that's why there is some loss here. Okay, recover this loss with the help of laminating the core. Okay, and third, sorry, there is the fourth last, and that is hysteresis loss. Hysteresis loss. So what is hysteresis loss? The magnetization of core is repeated, okay, by the reverse of alternating magnetic field. So there is some reverse here. There is some reverse in repeated magnetic field. So we have perfect material to low hysteresis loss. So we choose a very perfect material. That perfect material gives that a very low hysteresis loss. Then there are the some disadvantages here. We recover these disadvantages, get a maximum desirable output. That's the basic of transformer. Okay. So if you have any doubt, please ask in comment section. I will try to give the answer. So we complete the chapter number 7, AC current. Okay. Next class we discuss electromagnetic waves. So today in the class here. Thank you.